Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a concept of multi-stage centrifugal pumps. Uh, Up to now, we have discussed about the single-stage centrifugal pump. Now we'll discuss about multi-stage centrifugal pump. Actually, centrifugal pump where only one impeller is present. And when you talk about the multi-stage centrifugal pump, in this multi-stage, at least two or more than two impellers should be present in the centrifugal pump. Then it is called multi-stage centrifugal pump. So what we can say, where two or more than two, okay, two or more than two impellers are present. Impellers are present in the pump, then it is called multi-stage centrifugal pump. And that impeller, it can be like, it can be mounted on like a single shaft, or it may be mounted on the multiple shafts. If you see these two diagrams, here you can identify that impellers are mounted one single shaft, another one is impellers are mounted in two different shafts. That also we'll discuss. And this multi-stage centrifugal pump, it is having like different functions are there. Okay, for different purpose it is going to use. So if you need to develop high head, one example I'll give. If you want to develop high head, if you want to develop a high head, or the you need to supply the water with high pressure, so this is one condition. So you can fix the pump in series condition. So the pump, the centrifugal pump need to be connected in the series connection. Okay, this is one. And suppose if you want to discharge more number of, like more quantity of liquid, so high quantity of, you can say high quantity of liquid. So if you want to discharge high quantity of liquid, then we need to connect all these pumps with the help of parallel connection. So one is series connection, another one is parallel connection. These two things are there. Okay. So we'll discuss one by one, like when the multi-stage centrifugal pump is with high head. So first one, I'll give a heading of the first condition, this one. Okay, the multi-stage centrifugal pump, okay, for high head. This is the first condition. Let's discuss about this. Okay, so to develop a high head, a number of impellers can be used, or it can be mounted in different like in the series connection. So if you see, this is only one shaft is used here. Okay, only one shaft is used and two different impellers are used. So this is one pump, you can say, like if you take this part, this will be our one pump, and this is another pump. So this is like, as I told you, that each pump only having one impeller. Okay, so one impeller is present in each pump. So now if in this pump I'm going to connect two different impellers, like suppose this is one impeller and this is another one impeller in the one single pump, then only you can say it is a multi-stage centrifugal pump. Okay, so here now two impeller are there. Here two impeller is present in single pump, but one single pump. Okay, now this is one impeller and this is another one impeller. So here for this, like this will be our suction pipe. Okay, this will be our suction pipe, and from this the water will be goes and it will be like move to the next one, and again it will come here, again it will go to the next one, like delivery to this final position. Similarly here also the impeller number 1 and this is impeller number 2. So suction pipe and this is delivery pipe. Now if you see these two, let's suppose this is the first one. At this position the water enters. This is the entry part of the liquid. Okay, so if the water enters at 1 bar, suppose at 1 bar of pressure, if the water enters here, then when it is coming out from here, like in the first impeller, it will have, like, you know, suppose 5 or 6 some pressure will be there. So you can say, suppose here 5 bar pressure is there here. Now this 5 bar pressure is going to enter to the next impeller. Okay, to the next impeller here. Now if you see, this is the entry part, or you can say suction part for the next impeller. Okay, now this is the suction part for here, and here it is the delivery part. Again it is going to suck here, or that means entry part here, again it is going to out here. Now if you want to connect another one pump here, another one impeller here, again you can connect another one impeller here, and this will be entry for this, and exit from another part will be there. So the 5 bar pressure, when it is entering here, again when it will come out from this one, then it may have like 10 bar pressure will be there. So what I mean to say, when you are connecting multiple number of impellers in series connection, and that's why we can increase the head. We can increase the head. Initially the head was like, you know, 1 bar pressure is there. The pressure is at 1 bar, and when it is coming to the delivery of this outlet, so it's changed to 10 bar. That means increase the pressure. And how it is increasing the pressure, that I'll tell you here. So what is the process we can get it here. Let me draw another one diagram, small diagram, so that you can understand here. Like suppose here one pump is there, and we know that working principle of pump, like this will be our sump level or storage level of water, and from this storage level of water, with the help of the suction pipe, will suck the pipe from here, like this, of the water from here, and here will have the impeller will be there, and from this again it will come out from here. That means this is the delivery pipe, and this is our suction pipe, and here impeller is there, and also this impeller is mounted to the one shaft. Now again, if you connect another one pump, like see in the same shaft, okay, that one shaft will be there, either the shaft will be in this way, or you can connect in this way also. Now again, like what is the water is coming out from here with which pressure, then that same shaft, another one pump is connected here. So what is the water is coming out from here, so that is going to be suction for this, and from here it is going to out. But only one single shaft will be there. In single shaft, 2 different impellers are placed, or you can say 2 different pumps also you can placed in that. So what will happen, as I told you, that like 1 bar pressure here, it is how much, 1 bar pressure, when it is coming out here it is 5 bar pressure, again the 5 bar pressure is going to enter here, and finally it is coming out 10 bar pressure. So by this, if you see, our pressure increased here, or pressure increase. So as you know that pressure is directly related to the head, so if you increase the pressure, our head also is going to increase. So what is the process we are following here? So first step, we need to, like the fluid should be entered. The fluid should enter. So entry of fluid at the suction part. Okay. Second part will be there. The fluid will be entered the impeller. So the first stage, like first impeller is there. In the first impeller stage, okay, what is the process is there, like fluid is coming to this impeller, then the impeller started rotating, and from that the water is coming out. Okay, the next section is, that is intermediate difference, like, you know, what is the pressure difference from it when it is coming in and when it is going out. And the next one, this will be like intermediate section. In the intermediate section, actually I'll tell you the reason for this. In the intermediate difference here, actually we'll get the difference of pressure here. Now what is the kinetic energy which is present in this fluid, that is going to convert into pressure here. So at this intermediate difference, like at the intermediate section, the kinetic energy of the fluid is going to convert into pressure energy, or pressure difference here. Okay, this is the pressure. And how it is going to convert? So this is going to convert with the help of diffuser. Okay, with the help of diffuser. So in the multi-stage centrifugal pump, diffuser is going to use to convert the kinetic energy of the fluid to pressure, so that it is going to increase. Because if you see, if you directly connect number of pumps with a single head, a single shaft, then it's okay. But here only we are connecting all these impellers, and we are trying to increase the head. Okay, so by this we can increase. And the next one, the moving from here, once it is converted, then it will go to the moving to the second impeller, from first impeller to moving to second impeller. Okay, and if you want to again connect some more impeller, then again we can you can add some more impeller. Again, intermediate difference will be there, like with the help of diffuser will convert again kinetic energy to pressure energy, so that pressure will be increased here. And if you go for the third impeller, you can use third impeller, fourth impeller, how many impellers you want to connect, you can connect it, and finally it will be come out like final discharge. So when the water will be come at the final discharge, then we can see what is the head at that point, or what is the pressure will be there at that point. So that will become to the final discharge. This is for like head, like a multi-stage centrifugal pump for the high head abdomen. So now the second one, as a second one, if you see this one, so this is the second of pump when the pumps are connected in the parallel connection. When the pumps are connected in the parallel connection, or we can say when the impellers are connected in the parallel connections. So impeller is nothing but which is a part of in the pump. Okay, as I told you here that all impellers are, you can see number of impeller number 1, impeller number 2. Okay, similarly here if you see the impeller, this is one, pump number 1, pump number 2. So when we have connected more number of pumps in parallel connection, now as same thing again I'm going to tell here, this is our sump level where the water is stored, and from this, now see the first pump, let's come to the first pump here. So here this is the impeller part, this part is actually impeller, and this impeller is mounted on the shaft. Okay, here if you see here only single shaft, this is only one shaft. Okay, but if you see the parallel connection, here two shafts are there, one pump is mounted on the one shaft, another pump is mounted on the another shaft. So two different shafts are there. So this pump actually it sucks the water from the sump level and is going to strike here, then from here again the water is going to come out from here. So in the second case, let me write the second case. So second case is what? That multi-stage centrifugal pump. So here also you can write that multi-stage MS, here MSCP for high discharge. So high discharge, let me write in short form Q. So high discharge, how it will happen? Now very simple it is. Now if you see here, suppose we have as I told you that suction of water is happened here, then from here the waters discharge from here. Okay, now another pump is connected here. This is the common pipe where number of pumps are connected. So here if it is suppose the discharge came here 50, okay, the 50 meter cube per second suppose here, okay, and from this pump if suppose again the water come from here, then it strikes here, then it is going to out. So Q1 Q2, okay, so here Q2 equal to again suppose some 50 meter cube per second. Now if you see this 50 meter cube per second came here, again this 50 was added here. That means total if you see this Q1 plus Q2. So how many will be there? The total discharge now came 100 meter cube per second. So this much discharge came from by two pumps or two impellers, you can say. Now if you want to add another one pump in this, in another one connection, so another pump can be also connected in this. So if you multiple pumps are connected, multiple impellers are connected, obviously you will get more discharge. So to increase the discharge here, so we have added we have connected more number of impellers or pumps. So to find out the total discharge, okay, to find out the total discharge, we can calculate this total discharge equal to, you can write N into Q. N into Q. Now N equal to what? Now N is the, N I can say here, N is the number of equal pumps, number of similar pumps, we can say, number of similar pumps which are connected in parallel, and Q is the discharge from one pump, we can say. So how many numbers of pumps are used, you can multiply in that and you can get the total discharge. So discharge from single pump. Okay, so by this we can calculate here. So N into Q, this is the formula here. Now similarly, for this head also, if you want to calculate the total head developed, how much. So for the head also we can write, this is the total head. If I write total head is equal to N into HM, N into HM. So what is HM? HM, we know that is manometric head, or we can say the head developed by the each impeller. Okay, the head developed by each impeller, that is HM, and N equal to the number of similar impellers which is mounted on the single shaft. So here impellers are there, and here we have taken each single pumps are there. Okay, so this is the multi-stage centrifugal pump. Now with this multi-stage centrifugal pump is having some applications out there. So I'll tell you some applications. This is very common applications are there, which also we know, because when you discuss about the centrifugal pump also similar applications will be there. But as a multi-stage centrifugal pump, this can be used for other things also, because we are getting more high head, high discharge. So that is more important. So you can use this one as a boiler feed water supply. This is first one. The second one, I can say that irrigation system. We can use this for irrigation system. The third one, we can use, the most important is, like, you know, we can use this mining dewatering. When you work in the mining industry, to dewatering the mine area, we need this high head, obviously. So again, suppose high building is there, like a very tall building is there. So to discharge or to deliver the water to a long building, to a high building, so high rise, we can say high rise building. To supply the water at the high rise, we need obviously to with the help of this multi-stage centrifugal pump. Even in many more applications are there. Even also we can say we can use this in the oil and gas industry. Okay, and also the very common applications in our day-to-day life, like, you know, firefighting system. So in the firefighting system also we need to dispatch the water with a tall building, suppose. Then for that also we require this advanced multi-stage centrifugal pump. So fire system also we require. These are some applications, as I told you. Like, apart from this also, I can say some advantages of this centrifugal pump. Advantages of this multi-stage centrifugal pump. Okay, so what are the advantages can be taken for this? Very common, simple, I can say. First things we have seen that it can produce high pressure. It can produce high pressure. Again, also I can say along with the pressure also we can say high discharge also there, high flow. At the same line I can write produce high pressure and a high discharge. And due to that we can get high efficiency. Okay, high efficiency for high head. This one we can write high efficiency for the high head applications. And the flow, the smooth flow we can get from that, smooth and continuous flow we can get. So this is about the flow, smooth and continuous flow. Apart from this also I can write, like, it can be used in many areas. So as you have seen, applications is different areas applications are there. So we can see like versatile applications. You can see versatile application. This is one more advantages in this. So though advantages are there, even disadvantages also there in this. So let me just indicate few disadvantages. Few disadvantages of the multi-stage centrifugal pump. So in the multi-stage centrifugal pump, we can see the cost is a major issue. So the initial cost will be little bit more. So we'll get high initial cost. Obviously, the construction is a little bit difficult. So we can say complex in design or construction. Okay, this is one point we can add. Complex construction or design. Apart from that, also maintenance is required very much. Okay, maintenance cost. And yeah, so these are the points is enough. Even it will be not suitable for the liquid where high solid, solid liquids or solid contents of will be there with liquids. High solid contents with liquids is present means it is difficult to use this one. This is one more point in this. And apart from that also, I can say that maintenance cost is a little bit more as I'm informed here. So to make this equipment in the long life, some maintenance we need to do. Okay, what kind of maintenance? So as is the mechanical system, we can do some regular maintenance of this. Any kind of equipment we can do. Like for this, we can do some regular inspection need to be done. So regular inspection regarding what? So regular inspection regarding the alignment. Okay, whether all these things are proper or not. So alignment need to be checked. And we need to also, though it is a mechanical system, again I'm telling lubrications. So lubrications, oils or some other things are there means we need to check it. And lubrication need to be checked. Then suction, the suction pipe, okay, need to be checked or it need to be cleaned properly every day. Okay, and suppose any kind of items or parts are damaged, then that damaged part, okay, need to be clear from that. So some regular checkups need to be done for this. And these are the points are associated with this multi-stage centrifugal pump. So I thought to share with you, to discuss with you. I hope you understand this theory, the working principle of this multi-stage centrifugal pump. Of two types are there, and application disadvantages and advantages are there. I hope you understand. Still, if you are having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.